All right, good morning, everybody. Let's get going. Welcome to today's webinar about next generation control rooms. Let us quickly introduce ourselves. My name is Jeroen van Disseldorp. I'm founder and CEO of Axual, a vendor that delivers, designs and delivers ready-to-go Kafka solutions for the energy sector. And today I have with me Laurent Schmitt. Laurent, can you quickly introduce yourself?
Yes, good morning to everyone. I'm Laurent Schmitt, President of Digital for Grids. We are a small team of consultants specialized in data integration in control room environment. And I've been working 25 years in the power industry, starting at Alstom and GE, and then during 5 years at ENSOE.
All right. So the agenda for today, what we will discuss today, we'll go into the current and historic paradigms of energy grids and the traditional control rooms, what they have in terms of integration needs at the moment, given the energy transition. Then we'll do a look at what is Kafka for power. We have a couple of reference cases lined up for you, and ultimately a way to get going with Kafka for power. But first, let's look at the business side of what is currently going on in the energy sector and the energy transition. Laurent.
Yes, so why did we decided to launch Kafka for power today? We really see the control room environment to be the brain of all of this energy transition, which we see happening around us. These control rooms have been going through various phases of transformation through the last 30 years, moving through the various phases of improving grid stability when they were introduced 35 years ago, then going towards first steps of deregulation, introducing balancing and ancillary service markets, requiring first real-time interaction between control room environments and market operation. And then 10 years ago, moving towards deployment of smart metering, integration of control room into distribution grids, and starting to see the emergence of data integration from renewable generation. At that stage, we're large asset, large renewable farm. 5 years ago came the idea to bring demand response into the equation. That was started for larger distributed energy resource assets located into industrial sites, commercial buildings, and that's where we saw the expansion of the portfolio of data to be integrated into these environments. Further data coming from smart metering information. And today we are really at a new step towards introducing direct residential consumer data into these environments, looking at new data interaction through dynamic prices, and really taking advantage of all the new devices which gets deployed throughout the system, particularly behind the meter assets, such as bidirectional charging, heat pumps, or residential storage. So what we really see that through each of these phases, these have meant significant change into the type of computing to be done into these control room environments, and the growing expansion towards boundaries, which are not only substation, but really distributed energy resource assets going lower and lower into the power system. If we move to the next slide, so these various steps have been evolving through the various regulatory regime change, which are still ongoing right now in Europe, as what we know. I think the last regulatory change have been to introducing further market integration with the integration of flow-based, day-ahead markets, intraday markets, and then further integration of balancing markets together through a regional control center. And we really see the new phase coming in the next 5 years related to the deployment of the new flexibility code for demand side resources, as well as new electricity market designs, which open up for new schemes to enable interaction with distributed energy resources located behind the smart meter and potentially having a different flexibility service provider interacting behind the same main meter. So that really raised the complexity and the amount of data to be integrated into these environments, and in particular, the importance of using data standards, data exchange standards, to make sure basically connectivity happens as seamlessly as possible across the various layers, horizontally between TSOs, TSOs, and DSOs, as well as vertically with market participant, flexibility service provider, down to the control units and distributed energy resource assets. If we move to the next slides, what we see right now in terms of key use cases for the development of these future control rooms is really the further integration of virtual power plants into this control room environment, with key question on what is the level of observability which is required onto these distributed energy resource assets. Do we need a grid operator to see each of the individual assets to be able to properly manage their grid flows and congestion into each of the branch of the electricity system, whether at transmission or distribution level? But if we go further, we are also talking about further data integration into auxiliary service markets, gated residential assets participating into these markets, but also being able to calculate grid capacity and congestion forecast intraday as near as possible to the physical capability of the system. So that means putting together a very large sets of data and being able to compute them as near as possible to the 15 minutes time scale, as what we have now as a new reference in terms of market operation. And of course, considering new flexible grid connection, dynamic tariff management, potentially evolving towards dynamic tariff for grid tariffs, in a way incentivizing distributed energy resource assets at the edge of the system to smartly use the power system, considering that the power system is slower to develop and expand as compared to the introduction of solar or electrical vehicle, which have become exponential over the last few months. So, of course, on the top of this comes the question of the demand-side flexibility network codes and how to manage coordination of local congestion markets together with pan-European auxiliary service markets. All of that in a context where grid operators are expecting to publish much more data in real time for the purpose of making the market efficient on one side, but also now moving beyond the pure market operation use case towards such new use cases, such as, for instance, the monitoring of carbon origins, carbon emissions, and looking at 24/7 guarantees of origin, directly mapping with the grid flows and renewable injection at the various level of the power system.
All right, so then given all these developments, let's take a look at what grid control rooms start to look like. And when you focus on the grid control room itself, you see that data is flowing in from all sides into the control room, particularly, of course, from the internal side. So all the energy assets giving off data, that all is already integrated into the control room, but also from customer side and particularly market participant interfaces, data is ingested more and more into that control room, and also external sources are integrated. And to streamline all this, many organizations have already adopted a standardized process for ingestion, processing, and acting upon that incoming data. That's not something new, but what is new, that is that the volumes and the frequencies of this incoming data is growing exponentially. And control rooms are facing quite some challenges to keep up with this immense data growth.
this is, I would say, developing in a context where interoperability is becoming more and more important. So that means that basically the grid operator needs to look at assets within their grid environments, within their substation environments, but also across boundary and observability areas of their neighbor TSOs or DSOs. So that means exchanging power system information across different zones of these grids. So using standards like CGMES, which have been largely developed by TSOs through the NSOEs, as well as standards for developing from the 62325 European style market profile for all market data exchange. And what we see is that while we expand this data exchange beyond the pure boundary of the power system, new questions are arising about interfaces with behind-the-meter assets, and where basically new SIM expansions are being considered right now. So expansion of the same IEC standards to be able to interface electrical vehicle charging systems, heat pumps, and various type of control units. And we've been observing through various research programs recently from Horizon Europe, as well as in the US, some trends to evolve, basically the current standards derived from the IEC SIM towards these distributed assets. And so if we move to the next step, we've seen, for instance, all the definition of the semantic and data model being used for the objects of the grid infrastructure being progressively expanding down to a definition of assets into home and microgrids environments. And this has been prototyped and demonstrated in terms of feasibility in recent projects such as the Horizon Europe project OneNet, to what we contributed. So why do we think we need to? We are at a critical stage to move to these to such new OT architecture. We've seen that the current historical SCADA environments have had scalability issues when it comes to integrating basically data from prosumer and DR assets. These data are largely streams as opposed to SCADA technology being designed for the purpose of client-server type of data exchange. We've also seen that the expansion of data observability areas is increasing the need to combine all these data through a lower time granularity. I was mentioning the 15 minutes time scale becoming crucial to align physics from the power system with the grids. And that's going to become more and more true for intraday transactions in the future. And basically, if we are also looking at change I already mentioned in terms of data exchange and data interaction, moving to a publish subscribe type of environment. When you are a DER asset, basically you have to produce your data and publish your data to various grid operator, various flexibility service provider, and it's much more natural to publish this through a streaming environment than basically using REST point-to-point communication, which are much more complex to scale when it goes down to real-time interactions. That means also accelerating integration across enterprise. So the use of further standards, embedding standards and data exchange straight into the message exchange is very important. Making use of all these historical developments, but also going beyond the definition of the message itself towards the definition of common semantic, common ontologies, and being able to map standards with each other. We've seen in the previous slides various group of standards, such as the 62325, 62970, 968, and now and further developing towards the DR. Each of them have their own sets of data. What is very important is not to merge all these data sets together, but being able to map this through common reference libraries, which we think is important to move into a future OT architecture to facilitate such integration. And then, of course, on the top of that comes the topic of end-to-end data security. So from two perspectives, one is securing transaction between enterprise. That's basically being able to share and reuse certificates across different entities, but also being able to properly separate privately and own data from basically data which are less restricted. So all that means creating different layers of data security, for which environments such as Kafka have been emerging already into control room environments, but have not been necessarily easy to deploy in the perspective of sound data security strategy. So creating a layer on the top of Kafka to properly manage security, we think, is absolutely essential to accelerate deployment of this streaming technology in control room environments. And of course, we all hear about the benefits of using digital twin simulations, AI, machine learning. There's lots of tools coming onto the market. And one of the criticality into the control room environment is how to make use of these tools, which do not necessarily come from the traditional SCADA vendor, but from different app provider perspective, and how to integrate all these through the real-time data exchange process in order to make and maintain a grid operator decision for real time and progressively move towards automated control room environments.
Right, so let's take a look at what is Kafka for Power exactly. Kafka for Power itself is an orchestration tool using open source technologies that is able to facilitate all the data exchange in the new generation of control rooms. Basically, you can see it as a marketplace where applications exchange timestamped events whenever they occur. They can be shared directly onto the platform in a controlled and a secure fashion. And of course, well, these business events could be anything. It can be data that comes off of your DAR resources, but could also come from market participants or from external data sources. Here you see a picture of what a typical deployment would look like with all kinds of applications around it, and different applications also processing the data and feeding it back into the Kafka system. So what could that standardized deployment look like? Well, here you see a typical example with a data flow going from left to right, where different connectors could be supplying data to the control room in a standardized fashion using standardized message types being picked up by control room applications, processed and sent to external sources again in the control room or outside for reporting and dashboarding. In order to go to a next generation control room, more and more will be standardized on open source and open standards, which is why it is also important that Kafka for Power comes with a number of connectors, which make it very easy to connect these external sources and bring data to the platform from sources or offload data from the platform to external data systems again. Connectors make it really easy to do so, and tapping into the standardization that is already occurring worldwide in terms of these standardized sources and sinks. Well, the way we see Kafka for Power growing in organizations is, well, you usually start on the left here with, well, incidental event exchange, typically without doing any Kafka just yet. Often then a project comes along and says, well, we need Kafka because we need to exchange information between 3-4 applications for a particular use case. But at some point, there may be multiple Kafka systems arising in an organization and in and around the control room. And at some point, somebody will always say, let's centralize this, because it makes sense that all these applications, they need to exchange information with one another. So instead of bringing information here and there all over the organization, let's centralize this Kafka platform to make data exchange happen at a single location, which becomes then the default go-to location for getting and sharing the data. This is typically the phase where most organizations have difficulty, because it means that you would have to cross a few boundaries in terms of you won't be able to cut corners anymore for security and governance. You need to have this all well thought out, and you need to have the tools and the ability to facilitate this securely and privately without influencing your neighboring data exchanges. But if you manage to pass this stage, you can make it into the more advanced and pervasive types of Kafka deployments, where you start to not only exchange data in your organization, but also with other organizations, both on private clouds as well as in public clouds, where events ultimately we see are being exchanged between all market parties.
So if we are looking of what Jeroen is mentioning through the perspective of future TSO-DSO coordination in particular, I think what we can really consider is not only looking at Kafka in a single control room environment, but as what we were saying before, we do see Kafka entering several control room environments already, because the majority of the SCADA vendor today have now moved towards opening up their environment towards Kafka connectors. And I think one of the very interesting steps, while we see these growing needs of interaction between TSOs and DSOs, in particular to monitor congestions and run joint capacity calculation, is to think on ways to further standardize deployment of this Kafka environment in control room, so that basically Kafka topics do not only stay, I would say, within the boundary of the frontier of a single control room or grid operator, but some of these topics can open up and directly be used for data exchange across enterprise through very secured environments. So the benefit of such integration is, on one side, is that we take the full advantage of real-time performance, as what have been observed for SCADA integration, SCADA data exchange through the data exchange such as ICCP, for instance, but taking advantage of message structure model, which directly embeds basically standardized payloads and standardized data description, which is integration of SCADA information or state estimation information or capacity calculation information into the application. So in a nutshell, state estimation being run by a TSO on one side could be shared and reused partially by a DSO and vice versa, as an example, or the same calculation could also be used by a market operator, taking advantage of real-time data being updated in a local flexibility register, taking into account what are the latest DR flexibility available in a certain area of congested distribution grid. So we really see that with such an organization, we take the advantage of tightening the data exchange within the control room environment through real time, but as well as across different control rooms, making best advantage of new standards such as the SIM. In the same time, we are not constrained about the deployment environment, where we can have several combinations of deployment in on-prem environment for very secured grid control room environment, combining with public-private cloud environment, or even complete private cloud environment related to market operator, and keeping each enterprise strategy in terms of securing its own data infrastructure and running its own instance of Kafka. So really what the benefit of Kafka for Power is not only to think about Kafka around the layers of your own SCADA and control room environment, but already anticipate that the data exchange, which you know will need to happen with the various market participants or TSO, DSOs around you, and take best advantage of standardized message payloads.
So let's take a look at an organization that is already doing this. TenneT, leading DSO in the Netherlands and a third of Germany. They're meeting the challenges posed by the energy transition by wanting to get real-time situational awareness in place, having advanced analytics and control capabilities supported by AI. TenneT sees these capabilities as foundational for handling large amounts of data coming in at high speed, which are being processed at a continuous in a continuous fashion and acted upon in real time. And in order to get the data platform in place, they wrote out a European tender a couple of years ago, where they selected Kafka for their on-premise streaming platform. And the Kafka is, well, a core component to integrate all kinds of data from different sources, streaming data for a loaded frequency control, structured data, and business events. They all come together on the streaming platform to further progress the insights that TenneT has in managing the grids. The platform is currently operational. It's in production. And expects to onboard new use cases soon.
Another example of such deployment, which is more on a research basis. So it's in the context of the development of future European energy data space, to what Digital for Grids is contributing to one of these pilot projects called as EDI. It's for us an expansion of some of the development which we did through the OneNet project, where we are investigating basically option of using Kafka not only within the boundary of a single organization, but really across organization and across various layers of TSOs, DSOs interactions with flexibility service providers, and using Kafka with 62325 data exchange, embedding the basically data format straight into the Kafka topic, as well as for data exchange between flexibility service provider and DR operator, as well is now foreseen into the new flexibility network code, where there is a new layer basically introduced between the flexibility service provider and the DR, recognizing that nowadays most of these DR are internet connected, and this layer is a way to offer flexibility to consumer to switch from their heat pump or car charging from one service provider to another one. So really what we do have in mind here is to maintain the philosophy of data streaming across these layers, from the heat pump storage up to the level of the control room environment, through various layers of Kafka instance being implemented across different member states for data exchange, and serving the purpose of automating as much as possible the activities of flexibility service provider in view of their interaction both in local DSO flexibility markets as well as with pan-European balancing markets such as Marie, Terre, or Picasso. So that's really, we think, is a very interesting use case, demonstrating the feasibility of using Kafka not only within a same control room or market environment, but really going beyond, down to the market participant side and ensuring data consistency as much as possible from the DR up to the control room environment.
And the third and final reference case is on Eneco. Eneco's energy producer, which acknowledges that real-time data is playing an increasingly important role in the whole energy transition. A few years ago, they put a platform in place that could deliver upon the needs for having real-time data everywhere in the organization and being able to share that between different consumer and producer applications. They introduced Kafka in the standardized fashion, offering it as a platform to their development teams. And the use of a standard product and standard functionality allowed them to very quickly map and implement the first use cases on that. So initially starting out with typical application, ERP, CRM integration. They later moved on to integrating points of their heat net into the Kafka platform, allowing them to balance energy more efficiently based on the information coming in from people's thermostats at homes, and also the heat that was available in the system. They moved on to all kinds of marketing use cases, and recently have also implemented a next generation mission critical platform for their trading department. At present, there's the management of DER assets through a virtual power plant. I think to give some stats on the size of their implementation, there's currently around 50 teams working on the platform with 220 users. Around 200 applications are connected, sharing 130 million business events per day. And this is a typical use case that we see more often. So that may make you wonder how to get started with Kafka for Power. Typically, we see two kinds of stages in which organizations may reside to get going with Kafka for Power. If you're really early stage, then you may want to do an EDA readiness check. So checking your goals, challenges, and current architecture to research whether you are ready for an event-driven architecture. Typically, a session like this takes 2 hours, where the different approaches can be discussed on how to get going with a first use case. If use cases are already thought of, then you may be in the second stage and ready to discuss these specific use cases, including, well, who's the stakeholder, what the relevant application and landscape looks like, and how to define a POC with relevant success criteria. In order to do that, you would need around 4 hours, and then the end of that session will be a concrete plan to work on the POC, to get it defined and to get it implemented, and also to validate that Kafka indeed can become part of your future application landscape. And with that, I think we've reached the end of the slides here, and we open up for Q&A. Are there any questions and answers to discuss? Also looking at our help here on the right. More Q&A. Where is the Q&A?
Maybe just in the meantime, a few words of conclusion from my side as well. I think what we see is Kafka is progressively being introduced in control room environment as a default option. I would say, considering the large amount of data having to be managed and integrated through consistent environments. And we do see basically that several of grid operators have started their deployments basically pretty much from scratch, having their own philosophies, deployment practices, and so on. And what we would also like to do with Kafka for Power, in continuation of the European energy data space, is to really try to federate and facilitate such developments and define basically deployment best practices, which allows and facilitates integration of this data environment together. So the Kafka for Power is really a layer on the top of the open source environment, which we hope will help to accelerate that particular environment and basically enable flexibility as deeply as possible throughout the TSO and DSO grids.
Meanwhile, I'm trying to open up the Q&A, but Zoom is failing on us, unfortunately. I can't see the questions.
So I see a question. Maybe I can ask the question, Jeroen.
Yeah, if you see the questions, then please read them out loud.
Okay. After data being ingested by a Kafka consumer, it can be organized in different Kafka topics. One could use use case could have a single topic with all PMU frequency. Another use case could have a topic with all data from a particular asset on a particular substation. In the end, each use case might drive a different topic organization in order to meet its requirement. Do you believe a standard payload can meet all possible requirements coming from all different use cases? So I think that's an interesting topic. So basically, what it raises as the question is the definition of topics in Kafka, which is, I think, one of the very important design elements of all these deployments. And that's where we would like to drive further standardization and align them as much as we can to basically the SIM data exchange standards and messaging. And we are not aiming for basically reusing exactly the same payload for each of the topic, but really more defining topic structures, which allows them to deploy through this topic structure the right message payloads and data standards. So that's the idea which we have in mind, and what we saw onto this current use case in this presentation is we now have experience with virtual power plant use case on one side, with TSOs and DSOs use case on the other side. So what we are aiming for is to take advantage of these use cases and come with an harmonized way of defining Kafka topics and design. Jeroen, you may want to add on your side.
No, I think that's exactly it. It's trying to leverage the knowledge that was gained in the different implementations and being able to reuse that knowledge in future implementations. And doing that in a standardized way allows other parties to also reap the benefits of the lessons learned from earlier implementations.
The other question is, what about digital twin? Is this a typical use case for Apache Kafka? Jeroen, you want to respond, or?
Yeah, I think a digital twin is something that we see mentioned sometimes. Of course, what is interesting is that you can not only use Kafka in your OT environment, but you can also export that to the IT environment, where you may want to have different models to validate what is going on in OT. And you can also record what is going on in OT and also play that back. So that makes for an interesting development use case of setting up a digital twin to also use the models generated there to facilitate future scenario play.
Yeah, and to complement, we see digital twins being sets of digital twins. So some are more for dynamics simulation, steady state simulation, state estimation, for instance, or some others for market simulations. And basically, they are probably different vendors and specialists for these various apps and digital twins. So I would see the Kafka for Power as the integrating environment through these various apps so that grid operator can make use of their best preferred digital twin options depending on the use case and the problem they are trying to solve. So it's Kafka for Power comes as a very complementary integration environment to digital twin developments. Another one, we are already using Kafka. Can I still use the Kafka for Power platform for this? Do we need to migrate? How does that work?
Good question. In principle, you would be able to reuse your existing Kafka platform. There is like a standardized deployment that Kafka for Power brings, but ultimately it's really about the management layer on top, which starts to facilitate new kinds of data exchanges that you haven't really set up on the platform just yet. It is possible that you may want to standardize over time on the Kafka for Power Kafka setup, simply to warrant the full security and the software development lifecycle of the whole platform. But this is definitely not mandatory. You're still able to control and upgrade and manage your own Kafka platform if you desire to do so.
Okay, another interesting question is who are the competitors in the field of Kafka deployments? And basically, I would add a question around that is basically what is the level of the platform which is open source versus the level of the platform which is kind of built on the top of the open source?
I think everything that deals with the data logistics that is fully open source. So all the data movement, Kafka itself, the surrounding components like schema registry or data distribution, that is all done as open source. So it's purely the management layer on top, which at the moment isn't open source. That is like a commercial offering that Kafka for Power brings on top. But should that layer ever be removed, then it doesn't affect the ongoing operation. It will only affect future changes that you may want to do on the Kafka platform.
Another question, are you supporting the latest version of Kafka? Any upgrade procedure? How do you manage basically the alignment of the open source with the Kafka for Power?
Yeah, that's done by a recent move in architecture. We are standardizing more and more with Kafka for Power on the standardized open source, which is really converging into, well, several technologies were out there in the past, but it's really converging into Strimzi-based deployments, which may or may not happen on OpenShift as a standard platform underneath. But that's really a direction that we see the open source market move towards. And it's also the direction that Kafka for Power uses under the hood. Some organizations may want to decide to set that up themselves and to control that themselves, which is fine. Other organizations with maybe less technical knowledge, experience, capabilities, they may want to go for the standardized deployment, which Kafka for Power brings out of the box.
Another question is, sim grid data represent large and heavy data compared to SCADA and I would say real-time data, such as phasor measurement data, which are really high-speed data sample. Do you believe Kafka can handle it from a scalability and performance point of view? So the question is basically the impact of the size of the message payload to the performance which you see onto the event streaming.
In terms of, I don't know if you want to comment maybe on the message format first, Laurent?
Yeah, so the message format is exactly what we are right now looking through the AD data space project. Is basically is the SIEM content, and I would say the message content, directly into the Kafka message, or do we keep it, I would say, stored in a separate database, and the Kafka message just highlights that an event has happened around this message? And I think there are the two options, but the way I see it personally is I do see the SIEM payloads evolving towards JSON and Avro, which are also very interesting technology now, which we can straight embed into the Kafka payloads. And I'm pretty sure that all this is going to converge pretty quickly, so that we can use straight Kafka with the with SIEM payloads, apart for the majority of real-time messages. Of course, if we are into exchanging complex grid model, that could be a very large size file, in which case we can always we keep the file stored on a database and simply refer to the events associated to the file change or others. So I think that's the beauty of Kafka is you can be smart in managing your streaming strategy depending on the type of file which you are handling. Jeroen, you want to comment on?
I think that's exactly the way that we see it being set up. If messages turn out to become bigger, then often either in a database, like you say, or on a blob store, you may want to store well the majority of the content. And using events, you can refer to these blobs in order to not make the events on Kafka too big. But having said that, it should already become quite big. So I would say over 1 megabyte in order to warrant such a mechanism. Otherwise, you can just still carry all the event states in the messages being shared on Kafka.
Mm-hmm. Another question is, how do you decouple and standardize between the different parties in such an ecosystem? All participants in a Kafka environment, on data level, on API level, other measures. How do we see basically the spread of Kafka across all these participants? Jeroen, you have a view onto that, or?
So let me see if I can rephrase and understand the question properly. You have all these integration technologies, and how is the Kafka adoption in the different market parties going on? Is that the question?
Yeah, the question is basically how do we see the expansion of this across market parties, and basically how do we see the standardization of data exchange into this context?
Yeah, I think what there's a couple of well, base integration technologies, integration patterns. We initially data was exchanged in large data sets using batch distribution and was also processed in batches. Then, of course, in the last 20 years, we were doing a lot of service-oriented architecture, web services, which have now become standardized on REST-based services. And we see event-driven architecture and Kafka mainly emerging as the third option for all this integration. And each of these integration patterns, they have their own merit. Data sets still have their own merit, particularly around reporting over certain periods of time. The integration of REST services mainly has the merit in command and control scenarios, but for data acquiry, so getting data in from different sources, the event pattern is emerging as well the default pattern to implement there. And that, of course, if you look at the original intentions of SCADA to do command and control of your assets, but also to get data of those assets back into the controlling system, then it's a combination, of course, of REST-based services, REST-based technologies and platforms, and also event-based technologies and platforms.
Okay, another question on utility clients. What are the other reference which we have beyond the three we mentioned? Maybe, Jeroen, you want to mention reference with DSOs in Holland as well?
Yeah, we have a couple of references with DSOs in the Netherlands, which may be of interest. So there are more than the ones mentioned, but not sure what kinds of use cases the question is typically about.
But can you name these reference? I suppose we can name this reference.
Yeah, so we currently have implementation going on at Stedin. There is a reference with Eneco, who is doing the smart meter data collection, gathering and processing. So those may also be interesting use cases. We have another reference in the energy sector for an energy trader who is gathering messages, information from all over the internet, from public and private sources, from market exchanges, to generate real-time dashboards that allow traders to act upon the information much more quickly than doing this with other types of solutions. So yeah, different use cases available.
Another question is this only for TSOs to share data internally or to share real-time data between different TSOs and DSOs? And I think this one I can respond. It's what we try to show is for the moment, deployment are mostly for internal data sharing around control room environment. But we do see very interesting development options, and that's the purpose of this data space environment, to also make use of this Kafka topic beyond the pure boundary of a single TSO or DSO, but really across market parties as well as TSOs and DSOs, especially if we properly harmonize data definition, data semantic ontologies, and we work on to properly defining the associated Kafka topics. What is the average go-live time to deploy such a system, Jeroen? Another interesting question.
I would say the average, well, it can be done in a couple of weeks, but on average, I would say it takes like 2-3 months to set up a proper system for production. And this has nothing to do with, the system itself not being standardized. I think it's really well standardized. The deployment methods are standardized. The security mechanisms are standardized, but it usually takes an organization some time to provide the internal IT resources, to discuss the security and sign off on it. Sometimes an architecture document has to be written in order to pass the second stage gate before deployment may happen. So it's usually these kinds of organizational requirements around setting up a platform like this that determine the amount of time taken.
Yeah, that's very interesting to underline. Is while we were collaborating with Axual, our background is really coming from traditional SCADA vendors and SCADA deployment, historical deployment, where my experience is that it is very complex to deploy this environment. It takes several years, and it has to go through a very rigorous V-cycle process to define specification and so on. Kafka really offers a different way to deploy, allowing to start pretty quick out of a very limited sets of applications, very focused use cases. And while the experience grows into the organization, to make use of it on new use cases and integrate further data into the environment. So it really, I think, brings new agility into control room environment, even though these environments still needs to be very protected, very secured, which we can take care of. Another comment was around creating enterprise dashboard for situation awareness, where a combination of weather data, lookahead analysis, probabilistic contingency analysis filtered through various areas. Yes, that's exactly the type of use case which we have in mind. So we've shown basically an high-level view of the typical apps which we find around Kafka in the control room environment. This is just an example, and what we think is Kafka is really allowing to integrate as many apps as grid operator wants, taking best advantage of what they can find on the market in terms of technology, still, of course, working with their original SCADA vendor for the traditional SCADA instead estimation application, and basically that's where there's significant benefit to move toward that strategy. So there was a question around that: do you think the dashboard can directly consume data from Kafka, or should there be another data layer in memory database that will ingest data from Kafka or organize the data in a proper way apps can consume? So basically, if we Jeroen, if we were to deploy a real-time situational awareness calculation around Kafka, is this fast enough to, in terms of visualization and in-memory database?
Yeah, typically the requirement is, of course, how real-time does the dashboard need to be? If it's really sub-second, I would say, then yes, the dashboard will definitely consume from some Kafka topic directly. Not even doing the calculation. The calculation is something that you may want to do outside of the dashboard itself, just making that specialized to displaying it as soon as possible. But the calculation can be done by different systems, and also the information presented on the dashboard can be done by the different systems. If the data is okay to be, like 10-second accurate, then of course you can store it in a database or in some other system and have the dashboard just periodically query the latest information from that database and display it. But if it needs to be all-time up-to-date and really real-time, then I would suggest to make the dashboard consume directly from a Kafka topic.
Okay, maybe a last question, also interesting, is using Kafka between market parties an interesting development. We see that Kafka over internet is not easy to make stable and secure. Are there any technical limitations that you see, and what is required to make this Kafka exchange work well between organizations through internet? Do you have any experience on that, Jeroen?
Yeah, you can make it work by, well, at least adhering to standards in the Kafka world. We've seen some parties that have adopted their own message formats and their own, well, in Kafka terminologies, their own serializers and deserializers, which make it difficult to exchange messages with other companies. But as soon as you adopt the common standards, so Avro, JSON, and you don't have any specific implementations for your organization, then it becomes really viable to exchange that information also over the internet. Kafka is by default capable of making connections secure. You can use specific connectors to do Kafka to Kafka topic copying. So that opens up the door to exchange only pieces of information and not all information that you have on your Kafka cluster. It's not like a full synchronize of two Kafka clusters. It's really the information that you decide to share. You can do that over the internet. And that need not be that Kafka is completely available on the entire internet by everyone. You can shield that off, of course, because most Kafka systems are by definition running in the backend of an organization. So if you open up, well, just the IP addresses of your business partners, that will definitely make it possible to exchange information on a, let's say, on a topic basis.
Okay, so I think we've run through most of the question. And by the way, the good news is we see standards from the IEC moving also to JSON and Avro, which I think is really a very interesting alignment. And that's probably where future energy data space are going to help further integration across these environments. So very interesting development. So I think we are coming close to an end. Jeroen, you want to have a few words of conclusion?
Well, I wish to thank everybody for attending today's webinar. I hope you found it interesting. And we're really looking forward to people that are open for discussions to find out if you are early stage or if you already think about certain use cases on how Kafka for Power could enable making those reality.
Yeah, on my side, same thing. Thank you for joining. I hope you realize that we are doing this mostly to accelerate development in control room environments, accelerate the energy transition, and debottleneck the current energy system. So we hope you found this discussion interesting. Very happy to continue on bilateral exchange and focus on your use case, or even form a joint user group on sharing best ideas on how to design future Kafka topics across common European energy data space. Thank you very much.
Thank you very much. Bye-bye.
Bye-bye.